Number 3, congruent triangles. So like I said, for this year, we're going to skip the proof part for now. We'll come back to it later, but we'll just get into the meat of the section, and we'll skip the proofs, and we'll come back later. Let's see here. CPCTC. That stands for corresponding parts of congruent triangles are congruent. It stands for that. Okay, I know that seems kind of probably intimidating today, but eventually you'll know it super quickly and you'll know what it means and how to use it. So we typically end up using that in a proof, but again, since we're not doing proofs right now, it might seem kind of like, why are we doing this? But it still helps us with solving triangles as well. But most of the time when we write CPCTC, it's because we're doing a proof. Okay, so CPCTC again. Two triangles are congruent if and only if their corresponding parts are congruent. Corresponding parts of congruent triangles are congruent. I'll explain what that means in just a second, but that's where it came from. Oh, you don't have that part, do you? Yeah, I would definitely write that part down. Okay. So if you look at these two triangles, do you see that angle A is congruent to angle what? X? Angle B is congruent to angle Y. Angle C is congruent to angle Z. So instead of 3 arcs, do you see how they did 1 arc with a tick mark? So you can do 3 arcs. It's not like not okay. But I think 3 arcs and 4 arcs and 5 arcs get a little muddy in the picture. So they usually do an arc with a tick like that, a tick mark. Does that make sense to you? Okay, but you can do 3 arcs if you'd rather. It doesn't matter. Whatever makes sense to you. So those 3 angles are congruent. So we've got half of the triangle being congruent. When they say corresponding parts, what that means is, since these triangles are drawn in the exact same way, like they're not flipped or turned. Do you guys see what I'm saying? Okay, so this, I guess, left angle and this left angle are corresponding angles. Not corresponding like 2 parallel lines cut by a transversal, not that kind. I mean like the lower left angle and the lower left angle. This top angle and this top angle. That's what that means. Does that make sense? Okay, so like angle A and angle Z would not be corresponding unless these two triangles were like flipped or turned or something weird. Okay, so now let's do the sides, and I would write this down if you haven't already. Okay, so I'm going to start with side AB, line segment AB. Okay, how many tick marks does that have? Let's just say that. 2. So which other side or line segment on the other triangle has 2 as well? XY. Line segment XY. Do you guys understand that line segment AB is congruent to line segment XY? Okay. So now I'm going to do line segment BC. How many tick marks does it have? 1. So which one do I want on this triangle? YZ. Very good. That has 1 as well. Okay, what have I not said yet? Line segment AC, congruent to line segment XC. Do you guys see that I have 6 things? I have 3 pairs of angles and I have 3 pairs of sides. Does everybody get that? Okay, so what we've done is we've proven that these two triangles are congruent because all 3 corresponding angles are congruent and all 3 corresponding sides are congruent. When I use that word corresponding, that's actually incredibly important. What it's saying is this side is congruent to this side. It doesn't necessarily mean all 3 of these are congruent to all 3 of these. It means each corresponding piece is congruent to each corresponding piece. Am I making sense? Okay, so it's saying it's not necessarily an equilateral triangle. Okay, it could be, but it's not necessarily. So this part here, order matters. This is called a triangle congruence statement. So especially when we get into proofs, we're going to have to write those a lot. So you can name the first triangle any way you want to. You can name the left triangle, the right triangle. You can name it in any order. It doesn't matter. So typically, I start on the left. Typically, I go in alphabetical order. There's no rule to that, though, okay? So if I say triangle ABC, the second triangle matters how you say it. So if I say A to B to C, if I said A to B to C, you have to say the second triangle in the exact same way with the corresponding pieces, okay? So if I started with angle A, that had 1 arc, right? So on this triangle, what angle did I have to start with? X, right? And then I said B with 2 arcs, so I had to say Y. And then I said the third one, C, right? So the third one. Do you guys see what I'm saying? So I'm going to show you another example of how you could have written this if you wanted to. Let's say I said this first triangle was BAC. That would be fine too, doesn't matter. So if I said B to A to C, I would have to say Y, X, Z. Do you guys see what I'm saying? That's right as well, okay? I could have said CAB, and then I would have said ZXY. Do you see? It doesn't matter. You can go clockwise, you can go counterclockwise, doesn't matter. But the second triangle matters. It has to match up exactly right. So here's what I want you to know. Sometimes you don't have the picture. So let's pretend they didn't give me the picture at all. I could have come up with all 6 of these statements just by this. If they didn't give me the picture, I would have said first angle congruent to first angle. I would have said middle angle congruent to middle angle. I would have said third angle congruent to third angle. Do you guys see what I'm saying without even seeing a picture? I also could have said the line segments as well. AB were the first 2 letters, so it's congruent to XY, the first 2 letters. Do you see how easy that is? That one statement, because you wrote it in such a particular way, tells us all this information. Okay, have I lost anybody? Super easy concept, right? Sorry if I over-explained that. It's super important. I want to make sure you get it. Okay? All right. Theorem 4.4. Congruence of triangles is reflexive, symmetric, and transitive. Have we talked about that in here yet? We have? No. Okay. That must have been in chapter, we skipped chapter 2, right? That was in chapter 2. It's you've talked about it before in a math class, just not in here. Okay, I'm glad this came up. So, all right, reflexive property. If you look in your mirror, you see your reflection, you see exactly yourself, right? Like you didn't change. Does that make sense? So that's the reflexive property, where you have the exact same thing equal or congruent to the exact same thing, right? So back in chapter 2, we would have said like if x equals 2, then x equals 2. It seems kind of silly, but when we get into proofs, you'll see why that exists. Okay, so nothing changed sides, nothing happened, right? That's a reflexive property. And then we have symmetric. So this, do you guys have the words? No. So R stands for reflexive, and then S is symmetric, and then T is transitive. So symmetric, you guys know symmetry, right? So like a butterfly has an axis of symmetry down the middle, right? So is this the left for you? So the left side of the wings and the right side of the wings are perfectly symmetric. They match, right? But they're kind of a mirror image of each other. Does that make sense to you? So again, let's go back to the mirror. If I raise my right hand, it looks like my left hand. So symmetric is if triangle ABC congruent to triangle DEF, then switch sides. Symmetric, switch sides, okay? Then triangle DEF is congruent to triangle ABC. That's symmetric. Switch sides, switch sides, switch sides. So back in chapter 2, we would have said if x equals 2, then 2 equals x. Isn't that still true? Isn't that the same thing? So that's a symmetric property. Again, it probably won't seem helpful until we do proofs, but it exists for a reason. You just maybe don't know why today. And then the transitive property of equality and congruence. You can use it for equal signs and congruent signs either way. That's typically where you have 3 things. So I don't want to look at these just yet. I'm going to say if 1 equals 2 and 2 equals 3, then 1 equals 3. Do you guys see that's kind of what it said, but not as confusing? If I have one thing equal to a second thing, and a second thing equal to a third thing, then the first equals the third. Skip the middleman. That's what the transitive property means, okay? So in this particular example with triangles and congruency, says if triangle ABC is congruent to triangle DEF, and triangle DEF is congruent to triangle GHI, then the first one must be congruent to the third one. If they're equal to the same thing, then they're equal to each other. Do you guys get that, or do you need like math, like 2 plus 2 equals 4, and that equals? Yes, yep, that'd be fine. Are you guys kind of okay? Okay. This will come back when we get to theorems, or excuse me, to proofs. All right, show that polygons are congruent by identifying all congruent corresponding parts, then write a congruent statement. So they want all 6 things like we had before, 3 pairs of angles, 3 pairs of sides, and they want like triangle ABC congruent to like triangle DEF or something. Does that make sense to you? Okay, so this time they didn't draw the triangles perfectly. Do you see what I'm saying? They don't match up. They've either been rotated or flipped somehow, so you have to kind of think about it a bit, okay? So I'm going to start with the angles. That's easier for me. I'm going to start with angle A. What angle is A congruent to? X. Everybody sees that, right? They're both 90 degrees. Easy, right? So now I'm going to do angle B. I typically go in alphabetical order just so I don't miss something. You don't have to, right? Angle B was how many degrees? 60. So what degree or what angle on the other one? Yeah, angle Y. Angle B congruent to angle Y. And then the only two we have left, you might want to check them, but we're probably right. Angle C congruent to angle Z. Everybody okay with the three pairs of angles? Super easy, right? It gets harder later, but for today it's easy. All right, so now we're going to do sides. I'm going to say side AB, line segment AB, and that's 2.5. So which side on the other triangle would that be congruent to? YX or XY? It doesn't matter. Either way. Everybody okay? All right. Now I'm going to do, I guess, BC. It doesn't really matter. BC line segment would be 5. So which side on the other triangle would I say? YZ. Very good. What's the third one I'm missing? AC. To what? XZ, ZX. Either way. Didn't matter. So we've got our 6 pairs congruent. But the second part of the question was write a congruent statement. That's triangle something congruent to triangle something. So again, I typically go alphabetical. So you can do the ABC triangle or the XYZ. It doesn't matter either way. I'm going to start with the left one. That's typically what I do. So I'm going to say triangle XYZ first. But you don't have to. Please know that that's not the only way to do it. Okay. If I said X to Y to Z, I said 90 to 60 to 30. Okay. So if I said XYZ, what do you have to say? ABC, very good. Please know that's not always going to work, that they're both alphabetical. It could have been XYZ in another question. It could have been like CBA or something like that. Please don't think they both always work out alphabetically together. That's not a rule, okay? Do you guys see how easy this can be? Everybody okay? Okay. Anybody still need that page? Great. All right. Polygon BCDE is congruent to polygon RSTU. So it's the same concept, it's just not a triangle this time. So because they said that two shapes are congruent, I still know without even looking at this picture, I could cover up this picture and I know without looking, angle B is congruent to angle R. Angle C congruent to angle S. Angle D congruent to, do you see what I'm saying? I still know all that stuff is true without even looking, okay? So they want us to find X. So X is on angle B. So I'm going to look at that information. You guys just told me angle B and angle R are congruent. So I'm going to draw that. B and R are congruent. Do you guys see that? Okay. So if they're congruent, that means they're really what? What's the same thing as saying that? They're equal, right? So 2x plus 9 is equal to 49. Solve for X. That's all they asked you to do, right? So subtract the 9, 2x equals 40, x is 20. That's all they wanted. They said find x, we found it. Don't flip yet though. Anybody have a question about that at all? Super easy. So this question could have been a bit harder. So I want you to know how to set up that whole picture if we had to. I just did the one thing they needed. But if I had to keep going, I could have said C, 2 arcs, congruent to S, 2 arcs, right? And I could have kept going with the angles. I don't want to totally fill it in for you because I think this is like your homework. But I want to show you how to do the sides as well. I know side BC, this one, is congruent to side, what? RS. Do you guys see how I'm setting that up? I know side CD would be congruent to side ST, and so on and so forth. Is that okay? So again, I don't want to do the whole thing for you because I think you'll have to use that later, but I wanted to at least kind of give you a hint. All right? Bless you. Backside. Draw and label a figure to represent the congruent triangles, then find X and Y. So they want us to draw a picture, which you should do anyway, right? Anytime you don't have a picture, draw a picture. So we're going to draw a picture. I'm going to draw triangle LMN and triangle RST. I just drew 2 random triangles. I didn't draw a right triangle. I didn't draw necessarily a obtuse triangle. I just drew 2 very bland triangles because I don't know anything about it. Does that make sense to you? Okay. I tried to draw them the exact same way. And I tried to draw them like if I put L here, I put R there. If I put M here, I put S here. You see what I'm saying? That's easier for me. I don't like to flip and turn pictures unless I absolutely have to. So this was easier for me to follow. So now I'm just going to label everything I know. Okay. So angle L is 49. Angle M is 10y. Angle S is 70. Angle T is 4x plus 9. Everybody okay? So they need x and y. Where do you guys want to start? What would be the easiest thing for you to do? The 10y equals 70. Angle M congruent to angle S. Is everybody okay with that? So 10y equals 70. So y must be 7. So that's good. Okay. Now what? What am I still missing? I'm missing the x, right? Well, what do we know angle T is congruent to? Let's start with that. Angle T and N are the same. Well, I know T, but I don't know N. What am I going to do?
Oh, well, you have 49, and now you have 7.
Mm-hmm. We know this is really 70, don't we?
Yes, you can do 180 minus 49.
Right. So you can plug that back in if you want, but we know it's 70 because that's 70, right? You can plug in the 7 if you want and call it 70. Or you're like, well, S was 70, so M is 70, right? So we would take 180 minus 70 minus 49, and that's how we'll find angle N. What do we end up getting when we do that? 61. Very good. So I know that 61 equals 4x plus 9. Did you guys see how easy that was? Okay. So go ahead and solve for x. Subtract the 9, divide by the 4. And what do we get? Should get 13. If you don't, make me show you that work, but I might as well. If you subtract the 9, you get 4x equals 52, and then you divide by 4. That's where the 13 came from. Did I lose anybody anywhere? Pretty easy concept, right? Let me jump to your homework really quickly and see if there's anything else you have to skip. Obviously skip 22, but yeah, there's no other proofs on there. So you're just skipping that one question. If I didn't already mark it on your homework assignment, I'm not sure. Let me save this real quick and then I'll tell you the plan.